Good day, guys. This is Group 23, and our presentation will be centered on radial flow turbines. So, in this presentation, we'll give you an insight on what radial flow turbines are and how they work, the different components and their roles, the types of radial turbines and their applications, how the first law of thermodynamics relates to energy conversion in turbines, and finally, the key takeaways about efficiency and performance. Introduction to turbines. So one may ask, what's a turbine? And so, a turbine is a mechanical device that converts energy from fluid flow into useful work. Turbines can be classified based on fluid direction or energy direction. So, radial flow turbines is based on fluid direction. Radial flow turbines are a category of turbines where fluid moves in a radial direction, either inward or outward, before exiting. The working fluid can either be water, steam, or gas, but for the purpose of this presentation, we will focus on water turbines. And so, the types of radial flow turbines are the inward radial flow turbines and the outward radial flow turbines. An example of radial flow turbines include the Francis turbine and the Phoneron turbine. So, how do the radial flow turbines work? Water enters through a spiral-shaped inlet, thus making the guide vanes direct water tangentially onto the runner, that's the rotating part of the turbine. And so water exerts force on the vanes of the runner, causing it to spin. The adjustable guide vanes control the water flow, optimizing the turbine efficiency for different flow conditions. Now we are down to the parts of a radial flow turbine, and so we have casing. So the casing is always full of water to ensure continuous flow. Water enters through a penstock, and a penstock is like a gate or a pipe that regulates water flow in a hydroelectric system. And so water enters through a penstock and moves into a spiral shaped casing. This ensures that water enters the runner at constant speed. And we have the stay vanes. Okay, so the stay vanes, they have fixed component that reduces swelling effects of water, and it helps the streamline water flow, increasing turbine efficiency. And we have the guide vanes too. The guide vanes, they are installed around the turbine runner, so they direct water to hit the runner blade at correct angles to prevent shocks, and it can be adjusted to control power out. It can be adjusted to control power output according to demand. We have the runner too, and the runner is the main rotating component that converts water energy into mechanical energy. It has a curved blade designed for effective water flow without turbulence. So it's connected to a shaft which transfers rotational energy to a generator. And lastly, we have the draft tube. So it's a tube that guides water out of the turbine after passing through the runner, and it reduces pressure loss and improves efficiency. And as displayed on your screen, you can see the parts of the radial flow turbine. So let's watch this video to get a better understanding of what I was saying.
What is a radial flow reaction turbine? Radial flow reaction turbine is used at places where the water pressure is utilized to run generator at a very high speed, thus producing electricity. Radial flow reaction turbine in which enters a spiral-shaped casing. This casing encloses runner shown as. The water after passing through the casing flows through runner in radial direction. Now water as passes through the runner, a part of its pressure energy gets converted to kinetic energy. Thus we can say that water inside the runner is under pressure. Due to this, the runner rotates at a high speed. As a result, the shaft attached to this runner also rotates at a high speed. This shaft is further connected to a generator, which produces electrical energy, converting from mechanical energy of shaft. This type of turbine in which water flows radially and possesses both pressure and kinetic energy is called radial flow reaction turbine. Thus, radial flow reaction turbine is a hydraulic turbine in which water flows in radial direction and possesses both kinetic and pressure energy at the inlet. Related terms are
Okay.
And so now let's look at the radial inflow turbine. And so fluid enters at a large diameter and exits at a smaller diameter. It is used in a wide range of applications, from large hydroelectric power plants like the Francis turbine to small gas turbine in like spacecraft. So most common application is the turbochargers for engines, natural gas and diesel plant units. The Francis turbine, one of the most widely used inward flow turbines. So for the radial outflow turbines, fluid moves outward from a smaller diameter at the center to a large diameter at the outer edge. Less common than inward turbine, but still used in certain applications. Now we look at the first law of thermodynamics and how it affects the radial flow turbines. So the first law of thermodynamics, which is also known as the law of energy conservation, it says that energy cannot be created nor destroyed, but can only be transformed from one form to another. And mathematically, it can be expressed as Q plus W, which is equal to change in U plus change in PE plus change in Ke, where Q is the energy, the heat added to the system. W is the work done by the system. Change in U is change in internal energy. Change in PE is change in potential energy. And change in Ke is change in kinetic energy. So for steady states in turbines, the expression of the equation is expanded into its various components. And since turbines extract work, work of a turbine will always be positive. And the enthalpy of the water is converted into mechanical work. For the potential energy is often negligible, especially in high-speed applications. The turbine's efficiency depends on how effectively it transforms energy without losses. So, in conclusion, um, radial flow turbines convert enthalpy drops into mechanical energy. They are efficient for small and medium power range. Kinetic energy effects become significant in high-speed application. Heat transfer and potential energy effects are usually negligible. And so, thank you very much for your time and patience. See you in our next video. Bye.